The Bulldozer is a CPU made by AMD. Now, what's interesting about the Bulldozer is that it uses module technology. Module technology is partly dual-core processor and partly single-core processor. This is an interesting combination of processors, which is not randomly assembled. Modular technology allows for dual-threaded processors, which use the power of only one processor. Now, why is that important? Quiz. Why is a CPU that uses less power beneficial? A. The accumulator, or B. Money? Ooh, wrong, class. CPUs which use less power cost less to run, and this is why they are beneficial. Here is a photo of the Bulldozer's module, which we will now take a closer look at. The front end of the Bulldozer receives two work threads simultaneously and executes simultaneous sequencing of those threads. Where this comes in handy is called bursting, which is where AMD really specializes in its Bulldozer. What really matters in a CPU is how it handles large amounts of data at one time, a so-called burst. AMD believes that a large front end will not do the trick. However, it does believe that large amounts of executing power will solve the problem while avoiding queuing of data. This is why the Bulldozer has two execution cores. These execution cores use prediction-directed instruction prefetchers. In English, this basically means it can predict what type of data is coming in and where it should go out from the execution core. This is very useful because it saves time and therefore money. A prediction queue can manage direct and indirect branches that are now fed with a level 1 and level 2 branch target buffer and stores destination addresses. Bulldozer modules can decode up to 4 instructions per cycle, which is compared to the 3 on the AMD Phenom 2 processors, which was the processor created previous to the Bulldozer. You're walking down a dark alley and someone jumps out and asks you if you would rather your CPU decode 4 instructions per cycle or 3 instructions per cycle. You better say 4 instructions per cycle because then your CPU is faster, like the AMD Bulldozer compared to the AMD Phenom 2. If you survive the dark alley, we will now talk about the memory. Each execution core in the Bulldozer has level 1 cache with 16 kilobytes for data and 64 kilobytes for instructions, 2 megabytes of level 2 cache, and 8 megabytes of level 3 cache. You can read this as well as I can, so let's move on to the more important part, which is inclusive cache. What inclusive cache really means is that lower level cache can be saved in the upper level. AMD made the switch to inclusive cache because of its proven efficiency. Let's see an example to make this a little more clear. Here, in this example, we have Core 1 and Core 2, Core 3. Let's say Core 1's cache needs information from Core 3's cache. Without inclusive cache, Core 1 would have to go to Core 3, here, going from 2 to 3, and get its information. Now, Core 3 has been interrupted from the information has been working on for Core 1 to get its information. In inclusive cache, however, Core 1 can get the latest copy of the information which Core 3 is working on by just going to Core 2. Core 2 saves the upper level cache of Core 3. This is simple and fast because Core 1 does not have to interrupt the instructions of Core 3, so more processes can be done in faster amounts of time when cores do not have to be interrupted using inclusive cache. One of the biggest problems with the AMD Bulldozer is Windows 7. Windows 7 views the Bulldozer as 8 individual cores all working separately from each other. This is a disaster because of what I have talked about this whole video. The Bulldozer strategically uses its cores to increase efficiency. However, when they do not work together and work separately, this slows down the process. Also, because of AMD Bulldozer's large amount of cache, it works pretty slowly. At high frequencies, it takes the Bulldozer 40% longer to access its level 2 cache than it does the Phenom 2 processor. While we're on the topic of cache, we all know that a large amount of cache means a large amount of money, and this is very disappointing to some consumers who feel like they have paid more than they should have for the AMD Bulldozer. Of course, this is all relative to what you are looking for in a CPU. When speaking of processing large amounts of data, AMD is great because of its prediction technology. However, people who have bought the AMD Bulldozer for gaming have been extremely disappointed because of its slowness. Because of the disappointment of the Bulldozer, AMD decided to lay off much of its staff. They called it a rebalancing, where they hired people that would be more fit to do the jobs that were needed. Also, when creating the pile driver, the next edition of the Bulldozer, they added a F16C, which gives support for converting up to 4 half-precision floating point values at a time. The pile driver also features improved L2 cache. The minimal latency does not change, but the prefetcher and L2 are used more efficiently, and because of this, average latency has been reduced.